Good morning. I broke another tooth yesterday, so I am going to be out today. I'm here now at school, but I'm going to be out. So I just want to kind of go through this. So if you're in school today, you're going to be just basically getting your homework done and getting ready for the quiz tomorrow. I will be asking you to go to OneNote and do the assignments that were dated yesterday, which is January 11th. Do all the assignments that are in your homework tab. And I will put one more thing in your homework tab a little bit later on this afternoon, and it'll get you ready for the quiz tomorrow. You have a quiz at home tomorrow, so make sure you're ready. So yesterday we were talking about the potential energy diagrams, and here I have an exothermic, and here I have an endothermic. Okay, notice the difference. The difference between the two is that an exothermic starts high and ends low. It starts high and ends low. Where an endothermic, where it's going to absorb energy, is going to start low and end high. So that means the products have more potential energy. You can see that right here. They have more potential energy. And everything is labeled here. And you have to study this and know what things go where in preparation for your homework and certainly for the quiz. Remember, the heat of reaction is going to be the potential energy of the products. I actually write it like this: the products' potential energy minus the reactants' potential energy. Okay? So that's delta H. So it's going to be, if you look at the diagram, it's going to be letter A and letter H. I'm sorry, I think that's letter B. So delta H on that graph is going to be equal to letter B minus letter A. And if you do the math and you think about this mathematically, you're going to end up with a negative delta H value here, because you're going to take this small number, letter B, minus a larger number, letter A. So you're going to end up with a negative number. And just remember that all negative delta H's are exothermic. So if negative delta H, then exothermic. So that pretty much takes care of that. And then there's just a couple examples that I just want you to look at. Look up here, it says I have a chemical reaction and I have energy as a product. Energy as a product. So that means that the chemical reaction produces energy. The chemical reaction produces energy. Therefore, exothermic. That just makes perfectly logical sense. And it says right here that it goes from high potential energy to low potential energy plus heat. So I'm going to draw it for you here in purple. I'm going to start high and then end low. I draw the activation energy and then the energy given off, and then I connect the reactants to the products. Remember that these are the reactants and these are the products, and this space right here is what you get when you subtract the products minus the reactants, delta H. And remember, it's going to be a negative value because it's exothermic. This one is going to start low and end high. Start low and end high. So first my activation energy, then the energy that's given off, and then I go to the products. So reactants, products. Notice this has a much higher activation energy than the other one, because you're adding heat the entire time. You're adding energy into the chemistry of the products. So that's why that one looks different. And it's going to have a delta H. And it's going to be a positive delta H value. Okay, so now on to a few questions that will help get you ready. And that is your notes and some actual assignments. You can read here at the top. It's more basically the same. And then down here it says define endothermic. How can you tell from a potential energy diagram that it's endothermic? So reaction number 1, how do I know that this is endothermic? Because more energy goes in than comes out. More energy goes in than comes out. Or you could say that the products minus the reactants, that is this number right here, take this number, it's not labeled, but you could think of it as a number, that number wherever it hits the y-axis, and then this number where it hits the y-axis. If those two numbers, this one let's say is x, and this one's y, just hypothetical numbers, and I put them in there, x minus y equals a negative delta H. I said that incorrectly. That is a positive delta H. That's a positive delta H because I have a large number, letter X, minus a smaller number, letter Y. Sorry, I said that backwards. Okay, then the next question is, define exothermic. Exothermic is when more energy comes out of a reaction than goes in. So watch this. More energy comes out, that's this number right here, than goes in, which is right here. Mr. M explained this by pushing a ball, if you remember. If Mr. M has to push the ball, look at, I have to push the ball up the purple hump, but then it rolls all the way down the green line. So it rolls down the green line, which is the energy coming out, much larger than the amount of energy that I put into the ball, pushing it up the purple hill. A catalyst increases the rate of a reaction by lowering the activation energy. Remember, a catalyst creates an alternate pathway. So if you go up here to the diagram, when you diagram what happens to a catalyst, it lowers the activation energy. So on the one here on the left, I'm just going to get rid of that and just kind of show you this is the activation energy, right? So if it lowers the activation energy, what it does is it creates an alternate pathway. So instead of pushing the ball all the way up the orange hump from here all the way up to here, now all I have to do is go from here up and over the green hump. Notice that the catalyst, the action of a catalyst, let's go to the right, is up inside of this area. Okay? It can never be something like this, where there's no activation energy. Okay? It has to be up in the hump, so to speak. And then it says to draw and label a potential energy diagram, such as what you saw up there. I'm not going to do that. I will provide a key for you that you can look at in OneNote a little bit later on. And then the next two are basically just diagrams where you've got to fill in and answer some questions. And then there's some multiple choice regions questions. Okay? I'm going to do these with you, or I'm sorry, I'm going to do these and create an answer key, and then I'm going to put an answer key right over here in, I'm probably going to put it in your handouts tab. I'll put the answer key in your handouts tab. All right? So please get the homework done by midnight tomorrow. Please get the quiz tomorrow. You have a quiz tomorrow that's also due at midnight tomorrow. Okay? If you have any questions, you're welcome to call or find out, reach out.